Okay, so we're gonna do a little practice problem here. This, I've been asked about this question from the quiz. I think I can take this off. And so we're gonna do a little practice. So if for you watching this, look at the problem and then pause it. See if you can do it. And then I'll show you the answer and you can check. So we have a gazelle. Here's the question. We have a gazelle running here, and it's being chased by a cheetah. They're 15 meters apart. But the cheetah runs at 10 meters per second. I know it's a bad cheetah, I know. And the gazelle is running at 5 meters per second. And there's a fence 13 meters from the gazelle. So if she can get to the fence first, she'll jump over and the cheetah goes dinnerless. If the cheetah catches her before the fence, then there's going to be dinner. Okay. So the question is, first, where would they meet? If there was no fence and they just run, where are they going to meet? And then, does she get away? And you're going to have to find the time for this first. Okay, so if you want to practice, pause it here, and then you can come back and I'll show you the answer. Okay, so welcome back. I hope you tried to do it. So here's what we do. We say the distance traveled by the cheetah. I'm going to try to get a good marker here. Sorry, it's green. The distance traveled by the cheetah is equal to the distance traveled by the gazelle plus 15, because he's got to run 15 meters to catch up with her. And we really need to find how much time this is going to take first. Now you could do this a little different way, but this is the way that made sense in my mind. You could also say the distance of the cheetah minus 15 meters would be the distance of the gazelle. Now this is all constant velocities, okay, no acceleration. So we don't need to use the big three, we can just use our v equals d over t. And of course, if we're solving for d, then we multiply both sides by t, and vt is equal to displacement. So we know the velocities of these two animals. We don't know their displacements yet, but we want to find a place where when they meet, this is true. Okay, because when they meet, that's when the cheetah will have traveled 50 meters more than the gazelle. Okay. All right. So we would say this distance, based on this formula, the velocity of my cheetah times the time, should be equal to the velocity of my gazelle times the time. Now, these two times are going to be the same. We don't know what it is yet, but we know they'll have run for the same amount of time when they meet. And then, of course, I have to put in my plus 15. So we know the VC of the cheetah is 10. So we say 10t equals 5t plus 15. And then we just solve for t. So I'm going to do that up here. And we would say 10t minus 5t is equal to 15. And so 10t minus 5t is 5t. And we divide both of those sides by 5. And our t equals 3 seconds. So when they meet, it's going to be in 3 seconds. So 3 seconds will have elapsed, and then they'll be in the same place. Okay, so let's find the distance that the gazelle will have run in that time. Okay, we'll see if she gets by the fence or not. I'm just going to go up here again. Okay, so the gazelle's distance, her displacement, is equal to her velocity times the time. And so her velocity is 5 meters per second, and and we're going to multiply that by our time when they would meet, which is 3 seconds, and that is 15 meters. Happens to be the same as the original distance, but that's coincidence. So the distance that the gazelle will be when they meet is 15 meters, so that's here past the fence, and so the gazelle gets away, which I'm happy for the gazelle, but sad for the cheetah babies because they wanted gazelle, so hopefully they get something. But that's how you would do a problem like that. Keep in mind there's no acceleration here, and that's why we're using the Vt equals d formula. If there were acceleration, which could happen at some point, Hinton mentioned it to Wink, then we would have to use the big 3 to calculate where and when we would meet. But I'll show that to you later.